Good morning, students of class 5th. Today we will continue our chapter number 4 in maths, and its name is multiples and factors. Now today's topic is prime factorization. What is prime factorization? Prime factorization is finding all the prime numbers which multiply to make the original number. Here, there are two methods to find out prime factors, and the two methods are, first one is factor tree method, and the next one is prime factorization method. Let us solve the examples of both the types. Example 1 is find prime factors of 36 by factor tree method. Now we can start it. First of all, we will write down 36. Now we break it into multiples of two factors or two numbers. Let us do. We can write it in any two method, two numbers multiplication. For example, we write 18 multiply 2. Since 36 is an even number, so we will check it by dividing by 2. How many times we get 36? So divide it. 2 ones are 2. 3 minus 2, 1. Note down this 6. 16 divided by 2. 2 8 are 16. How many times? 18 times. That means we can write 36 as a multiple of 2 and 18. So we write here 36 as 18 multiplied by 2. Next, since 2 is the smallest prime number, that means there is no need to further break it. So now we will continue to break this. Again, 18 is an even number. So again, if we divide 18 by 2, then how many times? 9 times, because 2 9s are 18. That means we can write 18 as a multiple of 2 and 9. So we can write it as we will note down this 2 as now. These 2 and 2 are in its simplest form because these are the lowest prime number. Now 9, since 9 is an odd number, so we can break it. Divide by 3. How many times? 3 times. So we can write 3 multiplied by 3. And note down these 2. Now 3, 3, 2 and 2. We cannot further divide these numbers because 2 and 3, these are the smallest prime numbers. So we can write 36 in the form of multiply of its prime factors. We can write 36 equals to 2 multiplied by 2 multiply by 3 and multiply by 3. We can check 2 into 2, 4, 4 into 3, 12 and 12 into 3, 36. So this is a factor tree method how to find the prime factors of a given number. Let us find the factors of same number by the second method, and the second method is prime factorization method. Now, the same example, find prime factors of 36 by prime factorization method. Now, how can we find? Simple. Write down in this way. Right here, 36. We will select only prime numbers. We will start division only by prime numbers, and the smallest prime number is 2. So let us check, is 36 divisible by 2? Let us check it. 2 ones are 2. On subtraction 1, 1 down is 6. 16. How many times? 8 times. Remainder is 0. That means yes, 36 is divisible by 2. So write down here 2, and how many times? Write down here quotient. Quotient is 18. Again, is 18 divisible by 2? Now, next 18. 18 is an even number, and we know that even numbers are always divisible by 2, and 2 is also a prime number, so that's very easy. Divide by 2, and when we divide 18 by 2, then we will get how many times? 2 9s are 18, so we can write here 9. Now, 9 is odd number, so it is sure that 8 will not divisible by 2. Move to the next prime number, because we are finding prime factors, we are doing prime factorization. So after 2, the next prime number is 3. So divided by 3. How many times? 3 times. Because 3 multiplied by 3. 3 3s are 9. Next, 3. It is also an odd number, and 3 is also divisible by 3. How many times? 1 time, because 3 multiplied by 1, we will get 3. 3 ones are 3. We stop the process as soon as we obtain the 1. Now we can write 36 as a multiple of its prime factors. 2 multiplied by 2. Next, multiply by 3. Again, multiply by 3. 2 multiply 2, 4. 4 multiply by 3, 12. 12 multiply by 3, 36. So, this is the prime factorization method to solve our given question. Next, we will talk about co-prime numbers. Next is co-prime numbers. Two numbers are said to be co-prime if they do not have a common factor other than 1. That means two numbers are said to be co-prime if they have only 1 as a common factor, no other common factor. Let us clear it by an example. For example, factors of 4, and factors of 4 are 1, 2 and 4. Factors of 9. Factors of 9 are 1, 3 and 9. Now, which factor is common in both? We observe that 1 is a factor which is common in both. So we can write common factor of 4 and 9 equals to common factor of 4 and 9 equals to 1. Only 1 is common here. So we can say that 4 and 9 So we can say that 4 and 9 are co-prime numbers. Because these numbers have only one as a common factor. Next heading is twin prime numbers. What are twin prime numbers? Two prime numbers whose difference is 2 are called twin prime numbers. Here it is a necessary condition, compulsory condition, that we have two prime numbers. Both numbers should be prime and whose difference, that means gap between them is of 2, are called twin prime numbers. For example, three and 5. Both are prime numbers. 3 is prime, 5 is also prime. And difference, that means 5 minus 3. What is the difference? Larger number minus smaller number. Difference between them is 5 minus 3, that is 2. Similarly, 5 and 7, both are prime numbers. 5 is prime, 7 is also prime, and difference between them, that means larger number minus smaller number. Difference is 2. That means 3 and 5 are twin primes, 5 and 7 are twin primes. Similarly, there are many examples. 17. Third one is 41 and 43, both are prime. 41 is prime, 43 is prime, and difference between them is 43 minus 41. Difference is 2. That means these are also twin primes. One more example, 71 and 73. 71 is also prime and 73 is also prime. And difference means larger number minus smaller number. 73 minus 71, we will get 2. Difference is 2, and these are prime numbers. So these all are twin prime numbers. But in the case of co-prime numbers, it is not necessary condition that numbers should be prime. But in the case of twin prime numbers, it is compulsory that two prime numbers are needed. So, with the help of these topics, all of you can solve the questions of exercise 4A. And if you have any problem, then you can ask the questions through WhatsApp. Thank you.